take a look at a simplex problem. For simplicity reasons, we're going to a problem that's already been presented in the simplex document. We're going to look at example dairy is producing some milk, whole milk. And we give you the conditions that they must meet in terms of how many gallon type will be the maximum use and some other conditions. So this goes on how we know variables are defined, and the revenue function depends how much milk we have, as well as the other conditions must be met. So what they did was they wrote some equations, and if you have any questions about any of the equations or the conditions, please be sure to let me know. The part most people struggle is the actual simplex problem. The first thing we need to do is create what we call a linear programming problem, where we need to reduce this so there are no less than signs, only equal signs. We did introducing what are called slack variables. Slack variables take up the slack. For example, x is less than or equal to 100. I don't want the less than or equal to. What happens if I only make 400 gallons of whole milk? Then my slack variable, 100 gallons, it's taking out the slack, or what's left over, so I can make this an equality instead of an inequality. Now technically you can use any letters you like for slack variables. S, T, U, and V are some of the more common ones. They start at S for slack and then go up from there. So what they've done here is introduced the slack variable. For each equation that had an inequality statement instead of equality, we've introduced a slack variable, S, T, U, and V. You'll also see that in the last equation the X was moved to the left-hand side. The last step was to make sure that every single variable was equal to a constant. So in the revenue function, the R was moved over, and it was solved, so the R was positive and everything else was negative, and it was equal to 0. What we're going to do next is set up what we call a simplex tableau, and it's literally like taking and setting up a matrix. What you'll notice as we go down through these this set of equations right here, we're looking for the x column, 1x, 1x, 0x, negative 1x, negative 1.5x. So we're looking for the coefficients for each individual variable, x, y, s, t, u, v, and r. The last column is our answer, or our solution, after the equal sign. So this really does look like a giant matrix. Okay? What I've done for ease of use is I've gone ahead and put this matrix into an Excel sheet just so we can keep everything straight. Right? This helps because everything's tab delimited and we've got everything clearly defined into cells. After we've typed out our matrix, we do want to go ahead and identify what are called the basic variables. The basic variables have all zeros in the column except for one. You could see S, T, U, V, and R, or all of my slack variables, are also basic variables. They have zeros almost everywhere except for one entry. So I've dyed them yellow just to indicate that they're a slack variable. The slack variables actually become the row identifiers. So we'll identify this as S, T, U, and V, and R. Helps us identify our rows. Alright, we're ready to do some work here. The first thing we need to do is identify our pivot column. Okay? Our pivot column is identified by looking at the bottom row of the simplex tableau, or the simplex table. Look for the largest negative number, actually the smallest negative, the largest in magnitude, but the smallest or the least amount when you think about the negative numbers. The negative 2 is the lowest negative value. I'm going to dye that blue so you can see that. Within this pivot column, we need to do what's called finding a pivot row. And we do that, I'm going to put some scrap work over here on the last column by dividing the answer or the solution by that number of the pivot column. So 1,000 is my first solution, and the number 1 is in the pivot column in that row. The next solution is 500 divided by the pivot row column of 0. don't like division by 0. Then I have 650 divided by 1. Oh, by 1, not by a comma. And then I have 100 divided by 1. And lastly, 0 divided by negative 2. This is just some scrap work over on the side so I can see what the answer divided by that individual column is. What we're looking for here is the smallest number, or 1. This indicates my pivot position, my pivot entry, or sometimes called the pivot position. Now I do want my pivot position to be a number 1. It is, so I don't have to worry about that. Okay. This is where our linear algebra skills are going to come into play. We want to go ahead and reduce this so that all of the other elements are 0. So this is going to be my first table. I'm going to call it step 1, although technically it's not really step 1 because I'm creating a new table. Okay? So what I want to do is I want to get everything equal to 0. Well, I'm just going to go ahead and copy the T column because the T column already has a 0 in the pivot position. Over here, I'm going to write how my steps to get the 0. Okay? The first thing I want to do to get a 0 in the S column is say negative 1 times the V column plus S will be my new row S. Negative 1 times the V column plus, I'm going to try to write it out so Excel doesn't think it's a formula so you can see the work. It doesn't like that equal sign, so we'll just leave a space there. Is the new row S. Oh, come on. Okay. Apparently it's not going to like that. I'll try and get it in there as a text column. So my new row S, negative 1 times the V column, negative 1 times negative 1 is 1. 1 plus 1 is 2. I go over here, negative 1 times 1 is negative 1, negative 1 plus 0 is 0. Oh, I don't want to do that. I don't want to get rid of it in that one. I'm going to put it up here. There we go. Negative 1 times 0 is 0. 0 plus 1 is 1. Negative 1 times 0, moving over to the T column. Negative 1 times 0 is 0. 0 plus 0 is 0. Similar for U, V, and R. Negative 1 times 100 plus 1,000. 900. Negative 1 times V plus S. It does not like me. It's trying to outsmart me. Dang Excel. Alright, let's create a new U column. Similar idea. U has a positive 1 there. We want to do negative 1 times the V column and add them together. Negative 1 times 1 is 1. 1 plus 0 is 1. This cancels out here. That was the idea. And if you notice, going through the next three columns, negative 1 times 0 is 0. 0. Negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 1 is negative 1, plus 0 is negative 1. And then we have to be careful here. Negative 1 times 100 plus 650 is 550. Oh, not 550. There we go. Now we'll do our V column. Our V column is actually going to stay the same, the V row, because that's a pivot row. So I'm just going to go ahead and paste that. Next we'll do the R. Negative 1 and a 1 and a negative 2. Well, if we multiply 2 times v, so in order to make this negative 2 go away, we do need a positive 2 above it. Okay. Opposite of a negative 2 is a positive 2, so I'm going to take 2 times row v and add it to row r to make the new row r. 2 times negative 1 is negative 2 minus 1.5. Got to be very careful with your negative signs here. Is negative 3.5. Then we have 0. 2 times 0 is 0. 0 plus 0 is 0. And this actually occurs for the next 3 rows. Times v, or 2 times 1 is 2, plus 0 is 2. 2 times 0 is 0. 0 plus 1 is 1. And then 2 times 100 plus 0 is 200. And I did write over on the side what we were doing. Now, just in the interest of time and hosting privileges, I'm going to stop part 1 here, and we'll pick up the next step with part 2.